Hello everyone. In this video we are going to consider one question, mostly analysis and approaches mathematics IB diploma styled question, where we have to find the range of value k for which the line given by equation intersects the curve at this curve also given. Okay, first of all, let's try to understand how this looks like, what they're talking about. So you see the parameters are a bit confusing, and it looks like a very heavy and massive, not easy to understand what kind of curve we have and what to do next. First of all, let's focus on the parameter x only. So if you will look at the x parameter here in the first equation, you see that we have k, and since it is k range of values of k, it means that k is a constant. Okay, so first of all, let's underline that k is a constant. So k is some number. That is why the equation of kx plus 2k squared is very similar as equation y is equal to mx plus c, which is equation of the line. Okay, so it means that this k is our slope, gradient, and 2k squared is y-intercept. But it is not a focus of this part of the solution. But anyway, we should just here in this part understand that it is equation of the line. The same way, if we will consider the second equation, we see that since k is number again, we have equation of parabola, of quadratic function, which is parabola. So technically, we can say that we have to find the values of k where our parabola cross the line, or line the cross parabola, at more or equal to 1 point. So at least 1 point, yeah? So there are two possible options. First option is this one. Let's say that it is parabola and this is a line. This is a straight line. Either this gradient or this gradient, doesn't matter. Okay, and we have to find such k. So this k existing in two equations, it means that simultaneously affects two equations. Okay, so the idea is that we have to find the range of k so that the line and the parabola has at least one common point. Okay, so to say that they have a common point, it means that we have to equate their points, the coordinates of the points. Or technically speaking, we can say that we have to solve this system of equations. It is clear that we can easily use the substitution approach. Just let's equate the second equation with the first one. This is x, 3kx plus k minus 10 equals to kx plus 2k squared. Okay, now let's make it small and put it somewhere here. Okay, so now we have to first put everything to the left hand side and simplify to quadratic expression. So make sure that x is the parameter here. So x is a variable, k is a number, minus 3kx plus k minus 10. Just put everything to the left hand side. K squared equals 0 now. Now let's combine the like terms. 2x squared minus 4kx. And all these remaining terms are constant, so it's number. So we can say that here this is a coefficient, this is b coefficient, and this is big C coefficient. So ABC. So remember, the quadratic equation could be written in general form: ax squared plus bx plus c equals 0. Okay, now we know that discriminant shows how many common points these two curves have. So if the discriminant is more or equal than 0, it means that we have at least one common point. So it means the good idea is to find the discriminant. So discriminant is equals to negative 4k squared minus 4a, which is 2, and c. Our c is that much, minus 10. And let's simplify, open the brackets, minus plus 16k minus 8k plus 80. Okay, and the question is, find the range of values of k for which the line intersects the curve. Okay, so again we have to find the range of values where our discriminant is more than 0. Okay, so actually we have to solve this inequality. First of all, let's further simplify, and now we have to answer what values of k give us the expression where expression is positive. Okay, so we can split. We can say that 31k squared plus k squared is more or equal than 0. Why I did that? So you see here, this first term is always positive, more or equal than 0, right? The remaining 3 terms we can make as a complete square. So let's complete the square, plus 80. So we have to add here plus 16 minus 16. And now these 3 terms give us the complete square. And then minus 16 plus 80 is positive plus 64. So here, just don't forget to write one more term. And okay, now you see that this first term is positive, always positive, and this one is always positive because this expression under the square. So what we have positive number plus 64, or we can say it is always positive. So no matter what k is equal to, our expression on the left hand side is going to be positive. So we can say that this expression is positive for all values of k. For all values of k. So this is the answer. Let's just make a short revision what we have obtained. So it means that for any values of k, our parabola and the line will intersect the curve. Please subscribe, write a comment, press the like, ask any questions in comment so that I will know what next video is going to be about. Have a nice day. See you next video.